Now that we have reviewed simplifying radicals and factoring trinomials, we are ready to begin solving quadratic equations. In section 2.4, we're going to learn 4 methods for solving quadratic equations. This particular video will focus on solutions by factoring. Section 2.2.0, Introduction. Definition: a quadratic equation in standard form is an equation that looks like ax squared plus bx plus c equals 0, where the coefficients a, b, and c are real numbers and a is not equal to 0. The defining characteristic of a quadratic equation is this x squared term. If the highest exponent that I can find is 2 and there's no higher exponent such as x cubed or x to the 4th, then we have a quadratic equation. The presence of this term causes it to be a quadratic equation. Now, if that term is missing, we have a linear equation. And our goal in solving a linear equation is to isolate x. But now that we're dealing with a quadratic equation, we have a completely different algorithm or process for solving that particular equation. As I mentioned at the beginning of this video, we're going to learn 4 different methods for solving quadratic equations. This video focuses on solution by factoring. To solve a quadratic equation by factoring, we're going to be using something called the zero product principle. It goes something like this. If the product of two numbers, a times b, is equal to 0, then we know that either a is equal to 0 or b is equal to 0. I can't multiply two non-zero numbers together and get 0. If I multiply two numbers together to get 0, we know that at least one of those factors is 0. So we're going to apply this principle when we solve quadratic equations. So let's talk about the steps. Step 1 in solving a quadratic equation is to rewrite the equation in standard form. And by standard form, I'm talking about the standard form for a quadratic equation. Notice all of the variable terms and the constant term are together on the left and 0 is on the right. So step 1, collect all terms on one side of the equation leaving 0 on the other side. Once we have it equal to 0, then we can employ our zero product principle. Before we do that, we're going to factor it completely. So step 2, factor completely. And that's one of the reasons that we reviewed factoring trinomials. Step 3, employing our zero product principle, set each factor equal to 0 and solve for x, or whatever the variable happens to be. So at step 2, we're going to have two factors multiplied equal to 0. Employing our zero product principle, we're going to set each factor equal to 0, and this is going to create two little linear equations, and we're going to solve those by isolating x. That's going to give us two solutions. Step 4, check both solutions in the original equation. Check both solutions in the original equation. Just as a reminder, when we solve a linear equation in one variable, something like this, we're going to get one solution. However, when we solve a quadratic equation, we're going to get two solutions. Okay, so the degree of the equation indicates the number of solutions. And by degree, I'm talking about the highest exponent that I can find. So in this first example, the linear equation, I've got a degree 1 equation. I ended up with one solution. In the example of the quadratic equation here, I had a degree 2 or quadratic equation, and notice we end up with 2 solutions. Now on that example, I was just demonstrating the number of solutions, but let's actually practice solving quadratic equations by factoring. The most important thing to remember when you're solving by factoring is we have to have all terms on one side equal to 0. So in example 1, you look at this at first and think, cool, it's already factored. However, it's not equal to 0. So what we're going to have to do is break up these parentheses using our distributive property, move everything to one side, and then refactor. So distributing our x, we end up with x squared plus 2x equals 8. Now it's very clearly quadratic because I can see that x squared term. Let's subtract 8 from both sides. So we end up with the equation x squared plus 2x minus 8 equals 0. Now this is a quadratic trinomial and we've been practicing factoring these. So I'm going to get set up to factor this into 2 binomials. The first term in each set of binomials is going to be x. Now let's remember our sign analysis. We look at this term first, or this sign first. Since it's negative, we know that the signs in our binomial factors are going to be different. One's going to be positive and one's going to be negative. Then remember, we look at this sign. That indicates that the biggest factor should be positive. So I'm going to put the biggest number right here. So we need 2 factors of 8, 2 things that multiply to give us 8, with a difference of 2. Those 2 factors would be 4 and 2. The biggest one has to be positive, so the factorization is x plus 4 times x minus 2. Now remember, you can do a little intermediate check step right here and FOIL out those binomials to make sure you have it factored correctly. So the product of our first terms here is x squared, outside is minus 2x, inside is plus 4x, last is minus 8. Notice those 2 would combine to give me x squared plus 2x minus 8. So at this point, I know that I have it factored correctly, so I can proceed to solving the equation. So back to our work, we had x plus 4 times x minus 2 equals 0. We have 2 factors being multiplied equal to 0, so the zero product principle says one of those factors must be 0. So we're going to set each factor equal to 0 and solve for x. I can solve that first equation for x by subtracting 4 from both sides. That's going to give me the value x equals negative 4. And in the second little linear equation, we can solve by adding 2 to both sides, and that gives us x equals 2. So our solution set contains 2 values, negative 4 and 2. So the way I've written it here, I've put it in a set of curly braces just to indicate that we have a solution set. You can either write your answer x equals negative 4, x equals 2, or you can also put them together in a solution set. Doesn't make a big difference. Now, before I proceed, I want to make sure that I did that correctly. So I'm going to use my calculator to check both of those answers in the original equation. So I'm going all the way back to the beginning of the problem, and I'm going to start by plugging negative 4 in for x in both of those 2 spots. So we have negative 4, open parentheses, negative 4 plus 2, and this is pretty easy. You don't have to use your calculator for this. And we get 8, and we had 8 there on the other side. I'm also going to check 2, plug it in for x in both of those spots, and make sure that we get 8. So since our equation is balanced on both sides, then we are confident that we got the right answers. Now try to see the big pattern here. We started with a quadratic equation. I can see it right there. A quadratic equation, and we simplified it into 2 smaller, easier to solve linear equations. Later on, when we get to higher degree polynomial equations, we're going to be doing the same thing. We eventually whittle our equations down to some sort of linear equation. Okay, good job. That was our first quadratic equation. Let's try example B. 9x squared minus 12x equals negative 4. When we solve a quadratic equation, we need all terms on one side equal to 0. So I'm going to add 4 to both sides, and now we have it set equal to 0. Our goal next is to factor this. Now, notice that we have a leading coefficient not equal to 1 in this case. So when we break it down into binomial factors, we're going to have to consider the fact that our first two terms are not just going to be x and x. They're going to have coefficients in this case. But let's do our sign analysis. If I look at this sign, it tells me that both of my signs are the same. Same sign sum. So at this point, I know they're either both positive or both negative. When we look at this first sign, it makes the call. This tells me that both signs are going to be negative. So at this point, what I know for sure is that both of my signs are going to be negative. So I'm going to keep that decision firm and not change those signs. Notice in this one, both 9x squared and 4 are perfect squares. We know the first two terms have to multiply to give us 9x squared, and the last two terms have to multiply to give us 4. Let's use the square root of each of those numbers and see what happens. So we have 3x times 3x to get the 9x squared, 2 times 2 to get 4. Now, this is a trial and error process, so I'm going to take this little intermediate check step. So I'm making a break in my work and solving the equation just to verify that this step is correct. So applying FOIL, we have 9x squared, outside terms are minus 6x, same for the inside terms, and last are plus 4. Combining those middle terms there, notice we have reproduced the original trinomial. So that means we have it factored correctly, and we can proceed with confidence. Now this one is factored as 3x minus 2 times 3x minus 2 equals 0. This, by the way, is what is known as a perfect square trinomial. It's a trinomial because it has 3 terms. Perfect square because I could also write it as 3x minus 2 quantity squared. Okay, but let's see what happens if we just continue with the process we're learning, where we set each factor equal to 0. Well, I've got two identical linear equations. We're going to solve by isolating x. The first thing we need to do is add 2 to both sides, and then we need to divide both sides by 3. So we get x equals 2/3. And notice this would give me an identical solution, x equals 2/3. So in this case, we do have a quadratic equation. We got two answers, but they happen to be the same thing. This is what we call a double root. And later on, when we learn how to graph quadratics, that will mean something significant for the graph. So for now, we're going to indicate we have one solution. Now, let's double check our solution. I'm going to take 2/3, and I'm going to go all the way back to the original equation and plug that in for x. So we have 9 times 2/3 squared. I'm just going to press my x squared button there. Minus 12 times, and notice I'm implying multiplication with those parentheses, and press enter and it balances to give us -4. So we are confident that we have the correct answer. So quadratic equations have two answers, but sometimes you'll get a repeated answer like we did in example B. Now, on this next few set of examples, we're going to be considering other factoring methods. Don't forget about your other factoring methods. Example C is 3x squared minus 48 equals 0. We only have two terms here, and our goal is to factor it. So we're going to look at 3x squared and 48 and recognize they have a greatest common factor of 3. So I'm going to factor 3 out to the left, and dividing each term by 3, we end up with x squared minus 16 left behind. So notice 3 times x squared gives me 3x squared, and 3 times -16 gives me -48. So we have factored out our greatest common factor, 3. Now, what's left, the binomial x squared minus 16, is the difference of two squares. So let's review how we factor the difference of two squares. If we have something that's the pattern a squared minus b squared, it factors as a plus b times a minus b. If we have the sum of two squares, by the way, a squared plus b squared, this guy does not factor. We say that it's prime. So make sure you're paying attention to the difference between those two. So back down to our problem. This is going to follow the factoring pattern of the difference of two squares. So we're going to take the square root of the first term, x, and put that in the first two spots. One's going to have a plus, one's going to have a minus, and we're going to take the square root of 16, which is 4. So we have 3 times x plus 4 times x minus 4 equals 0. So to continue in this equation solving, we're going to set each factor equal to 0. But the question is, what are we going to do with this factor? Notice if I set it equal to 0, I get an absurd equation. That's never going to be true. So really, I'm not going to get any information out of that 3. Out of the other two factors, though, I will get a little linear equation for each. I'll be able to solve the first one by subtracting 4 from both sides and the second one by adding 4 to both sides. So our solution set then contains two values, -4 and +4. Let's verify both of those with the calculator. Build the discipline to always check your work, whether you're just mentally evaluating it or actually typing it into your calculator, so you can always be confident if you have the right answer. So plugging in 4 gave us 0. Let's check -4 as well. And both solutions give us a balanced equation. So we know that we ended up with the right answer. Example, the one below C with the checkbox is going to be very similar to the one that we just did. So I'm going to start by subtracting 5x from both sides to get all terms together and set it equal to 0. And then again, we're going to recognize we only have two terms, but they have a GCF of 5x. So if I factor out 5x, that's going to leave behind 2x minus 1. Now, never be afraid or hesitant to, it's not the end of the problem, but we can always check as we go. So I'm going to verify 5x times 2x gives me 10x squared, and 5x times -1 gives me -5x. So I know that it is factored correctly, and then I can set each factor equal to 0. So the first factor is a small one, 5x equals 0, and we'll set the second factor equal to 0 as well. Now, this one is different from the previous problem, okay? I want to draw your attention to this GCF and this GCF. They are different because the first one did not have a variable, but this one does have a variable. Remember, we said we do not get any information out of that greatest common factor. However, we will get a solution out of this one because we can actually solve this equation for x. So I'm going to divide both sides by 5, and notice we get our answer, x equals 0. So if your greatest common factor does not have a variable, you can ignore it. If it does have a variable, then you need to set it equal to 0 and solve for x. Let's solve our other little linear equation for x. Add 1 to both sides and then divide both sides by 2. So our solution set contains 0 and 1/2. Now, to double check, if I look at the original equation, clearly, if I plug 0 in on both sides, I'm going to get a balanced equation. Let's go ahead and check x equals 1/2. I'm going to plug it into the left side, 10 times 1/2 squared, and evaluate. I'm going to plug it into the right side, and my goal is to make sure that both sides yield the same value. Both sides are equal, so we know that we have the right set of solutions. One more example for this section, we've got a quadratic equation, and we're going to solve it by factoring. To solve by factoring, we have to have all terms on one side and set that equal to 0. So I'm subtracting 11x from both sides, I'm subtracting 6 from both sides. When I move a term from one side to the other, you're seeing the pattern that it changes signs. Next, we need to work on factoring this. This is one of our more challenging factoring problems because we have a leading coefficient not equal to 1. So before we jump into figuring out the numbers, let's figure out our signs. If I look at this last one first, because it's negative, the signs of our binomial factors have to be different. One's going to be positive and one's going to be negative. So I'm going to make that decision and I'm not going to change those signs as I factor by trial and error. The first sign is negative, so this one tells me the biggest one is going to be negative. Now, that's not necessarily the biggest number. In this case, it means the biggest product comparing your outside and your inside terms. Okay, so we're going to factor by trial and error, which means I'm going to pick my two favorite factors of 10x to put in this spot. So 10x squared. I'll pick 5x here and 2x here. We know those two have to multiply to give us our first term. Then I'm going to just randomly choose any two factors of 6. Let's go with 2 and 3. Okay, so we know that the first two terms have to multiply to give us 10x squared. The second two terms have to multiply to give us 6. So we're going to try something and see if we got it right. How do we know if we got it right? We check by FOIL. So here, our first two terms have a product of 10x squared. Outside terms have a product of minus 15x. Inside terms plus 4x. And last, minus 6. Combining middle terms, we have 10x squared minus 11x minus 6. Oh man, we got lucky on that one. We got it right on the first try. Keep in mind, it doesn't always work like that. If you FOIL it out and you don't get the same thing, then try something like switching those two terms or maybe switching the first two terms or trying different factors. But we have it factored correctly, so we can get back to our process of solving. I'm going to set each factor equal to 0. Now we're back to Unit 1, right? Solving a linear equation. Working on the first one, we can subtract 2 from both sides, and then we can divide both sides by 5. Our first solution is negative 2/5. The second equation, we're going to add 3 to both sides, then we'll divide both sides by 2. So we've got two apparent solutions, negative 2/5 and 3/2. I'm putting them in the curly braces just to indicate that we have a set. So let's double check with our calculator. I'm going to take my two values, starting with negative 2/5, and I'm going all the way back to the original equation, and I'm going to plug it in on both sides. So starting with negative 2/5, on the left side, we have 10 times negative 2/5 squared, and on the right side, we have 11 times negative 2/5 plus 6. And both sides give us the same value, so we know negative 2/5 is the correct solution. Let's check our 3/2 in the same way. Here's what it looks like when we plug it in on the left side. Now remember, I'm not really that interested in the value that comes out as long as it matches the other side. So both sides yield a value of 22.5. Be clear, my answer isn't 22.5. My answer is negative 2/5 and 3/2, the values which created that balanced equation. So that is our first method for solving quadratic equations. We can say 1 method down, 3 to go.